Good morning, folks. This is Duncan again at Free as an Eagle, and throwing in a little bonus track here this morning. I came up to do a little bit of work. This is Labor Day weekend. It's Saturday morning, and I'm staying local, trying to catch up on some things here I want to do, and also kind of rebalance my life, catch up on some of the domestic things that I've been putting off. It's very easy to get kind of obsessed with these projects and kind of let things go on the home front. My other house requires some maintenance, and my car does, and my relationships do, so got to keep everything in balance, keeping the must-dos and the wanna-dos kind of in balance so that nothing blows up. So anyway, I came up here and I thought I'd take a few minutes. I just actually wanted to share a few little practical geometry tips and tricks to help out anyone that's not an expert at this yet. If you're kind of a do-it-yourself DIY person or getting into a project, I might be able to save you a little bit of time and trouble by sharing a few of the little tricks that I've learned along the way. And some of them are geometric. I actually remember my high school geometry course, and I kind of enjoyed it because it helped you visualize things in 3D and allowed you to figure out some of the little things that are otherwise can be kind of pesky. So I'll try to make this kind of quick and practical. I drew a couple of little charts here just to illustrate. An A-frame basically is a triangular structure with many triangles involved. So when you're dealing with triangles, there's some geometry that can be helpful. So I'm just going to zoom in on these pictures and try to explain this if I can, such a way it makes sense. So anyway, so you're looking at a triangle in this first picture, and that represents one half of the appearance of this, say, from the front. And one thing about triangles, in any given triangle, all the angles add up to 180 degrees. Now a square, on the other hand, there's four 90-degree angles, they add up to 360. So a triangle is basically half a square. So you've got one 90-degree angle, and then when you calculate your angle, say, of a roof pitch, all the angles add up to 180, so you've got a 90 in there. If you subtract one of the other angles from 90, you get the other automatically. So this one, the up angle at the base, you can see on the right there, is a 64-degree angle. And I calculated that based on the fact I had 28-foot rafters. I wanted to get the maximum use out of them and get the maximum height with the A-frame. So when I did that, I could take 64 and draw out and to get practical, let's see if I can get in close to one of these that's not cluttered. But say the very bottom of the rafter where it's attaching to the building, you're dealing with a 64-degree angle, which is a bigger angle than a 45. It's fairly steep, and you're going up there to the peak. And then when you get up to the peak, you can see if you split that angle, the other half of that angle is 26 degrees. So you come in to a lot of situations where you're setting your saw to make a cut, and you need to use those angles. So it's nice to know what they are and be able to calculate them. So the next thing, oh, by the way, this little gadget, if you don't have one of these and you're dealing with angles, these things are great. It's a little guy that helps you calculate your angles. So if I set that on there and I align the main part of it with say this triangle, and say I wanted to know what the angle was. As a carpenter, I usually use a speed square, but when you're doing paper at a desk, these little guys are better. So if I line this thing up like this, then you can see that I've got a 26-degree angle going on there. And that's very handy. You can set that and you can draw pictures of these things. Okay, so the next thing is, a lot of times when you're doing carpentry, you build a deck frame, or even when you're laying out a foundation, you've got these big distances. Like this, before it became a building, was basically just a plot of land, and it was necessary to figure out where it was going to go. And actually, I had to stake out the foundation for the guy that was doing the site work so he'd know where to dig and how to orient it. So what I did with this, I wanted it facing due south because the lot lines actually face due south in this build. And so I went with that with a I tried some apps on the phone. They weren't too great. I finally ended up using an old-fashioned compass and a level that seemed to be about the best way to go, and I staked it out. But the only way to know that something's square when it's that large is if you have a square or rectangle which is composed of 4 lines with 4 90-degree angles. If it's correct, then the diagonals are going to be the same. So on this little illustration on the picture, I just drew this little rectangle, and if I measure the diagonals in both directions, they're 9 7/8 inches. So that means that it's square. If you rack a square, then one diagonal becomes longer and the other becomes shorter. So it makes a huge difference. If you're a little bit racked, it'll be pretty obvious that the diagonals, they'll show you that it's wrong. And you can kind of doodle around with the posts where they're put until you get it right. And one of the handy ways of getting it right, this is harkening back to the geometry days, is using this Pythagorean theorem. And people laugh at me for using this kind of stuff, but it's super handy. So the Pythagorean theorem, the way it goes, and we call it the 3-4-5 principle. It sounds kind of simple, but in a triangle, if you have things square, say you've got a 90-degree angle in that lower left corner of this triangle, what happens is if you take one side, say, and I just did 6, 8, 10 here because it works for any multiple, just to make it a little bigger. I drew that out with inches. So the Pythagorean theorem goes a squared plus b squared equals c squared. So in any right triangle, if you add the square of the two short sides together and then take the square root of it, then that's the third side. So for example, 3 squared is 9, 4 squared is 16. You add those together, you get 25. You take the square root of that, that's 5. So any multiple of this works. Now where does this get practical? Simply that, say you start to stake out a foundation and you got 36 feet by 24 feet, that's kind of large. It's kind of hard, you're walking back and forth a heck of a lot trying to get those diagonals to match, because you go to one side and it's not quite right when you measure the diagonals. You tweak the stakes over a little bit. After doing that 5 or 6 times, you've walked about a quarter of a mile. You're kind of sick of it. You want to find a way to get it right. So one of the most practical ways is you put a stake in one corner sort of to establish where you're going with this. Pound that in, and you say you go 6 feet in a direction and you put another stake. Then you walk 8 feet in what you think is the other direction, you put a stake. Well, then you'd grab your tape and you hook it over one of the stakes, pull to the other one, and if it's not the square root, you do a little bit of math, but if it doesn't add up to the square root of that length that you're now getting on the long leg of the triangle, then you've got to move one of them in or out a little bit to make it right. Once you've established the 2 lines by a little bit of trial and error in close range, then you can extend them out further and they'll be accurate. So this is extremely practical for squaring up anything. You can use it on a deck. Say you've got a long deck and you want to make sure it's square. You can do the 3-4-5 on the framing, and that'll tell you whether you're square, and then you can extend it out. You can use 6, 8, 10 or 9, 16, 25 or whatever, or it wouldn't be 25, but anyway, you can use any multiple of the 3-4-5 and that will work using that mathematical principle. So I've used these things a lot just to make sure things are correct, or to get them squared up initially, and that way you have less work to do when you extend the lines way out. You can tweak it a tiny bit and get results. So anyway, I just wanted to share those 3 things with you in the hope that'll save you a little bit of trouble and give you something to work with when you're working with a project and you have need of some of these things. So anyway, that's today's little lesson, and now I'm going to stop the video and jump on some of the little projects here. I think I'll finish up some of the papering on the roof that never got done, and then maybe cut the blocking for this overhang. I've got to put 2x8 blocking up and down this thing every 4 feet so we can hang the outermost rafters, and that will get us one step closer to getting the roof on. So anyway, I hope you enjoy, or will enjoy, your holiday weekend here. Weather's starting to look nice, sun's out, so enjoy. Take care. We'll talk to you next time.